be going through over threshold results of our 10-home study, the optimization of the MCHM analyses that were done by the laboratory. Today we're going to talk about 4 major areas, and I have a really good slide of this at the end. We want to understand what levels can be smelled, because we understand that the odor is a big problem. So one of the questions we had is at what level could MCHM or the crude MCHM be smelled? Could it be smelled at levels that are so low that they may be below the detection level of analytical instruments? And can those levels be, are all those levels well below the levels that have been determined to be screening levels? If they are, that may bring some comfort that you can smell it at levels that may not be of health effect to you. One of our jobs was to develop a sampling plan to determine how much MCHM is out there. So once we know what you can smell, we want to know how much is out there. We also want to then evaluate whether there are any breakdown products that may be of concern and may need to be looked at in greater detail. And then we also wanted to evaluate the screening levels. We're going to report on all these things, the screening levels. That work will be done, and we will report out again on that again on Tuesday next week.
Crude MCHM. One of the things that the West Virginia Army National Guard was incredibly helpful about was they went to a tank in the Poca blending facility and sampled that 100 milliliters of product that came from tank 396 on the property of Freedom Industries, the tank that spilled into Elk River. This is the material that went into the river, it went through the treatment plant, and it ended up in your homes and in the distribution system. This is actually PPH. This is a sample of just the pure MCHM, which you can go out into any chemical store and buy. The pure MCHM and the crude MCHM are different. They have different odors, and they react differently in water, and people smell them differently because there are minor components in the crude MCHM that have odor characteristics that make the licorice odor of MCHM much more intense. So it was crucial that we use the crude MCHM throughout all of this testing. There's tank 396. We went and visited it yesterday.
I'm Andy Welton. I am an environmental engineering professor at the University of South Alabama, and I will be talking to you today about the results of the 10-home study and their implications. This picture was one of the first images that we had during the 10-home study. It's a picture of Boone County, and I want to again thank all the residents of the 10 homes who participated in this study, because what we're about to do is show thousands of individuals' results of this testing, and it wouldn't have been possible without your help. Thank you. Before I dive into the results, I need to mention that plumbing systems are very complex. Plumbing systems in residential homes have different pipe materials, different diameter pipe materials. When the water enters a house, it may sit for a very long time as it travels to that extra bathroom that nobody uses, or the outdoor spigot. Water inside homes also undergoes temperature changes. It can be 6 degrees coming into the house, and as it sits inside an interior wall, it can warm up. Or you can send it through a water heater, and the water then can go up to about 60 degrees C. So there are very different types of water quality and conditions that happen inside residents. The objective of the 10-home study was not to canvass the entire 9-county area and to determine the average MCHM concentration or the average PPH concentration. The objective of the study was to determine the in-home variability, whether or not there are higher levels of chemicals in hot water or cold water, or whether or not it matters between which type of faucet you use to pull that water from. And also to interview some residents to find out what their experiences are during the spill. We conducted the 10-home study with Dr. Clancy, myself, and Tim Clancy between February 11th to February 18th. We visited 10 homes. We visited 8 of the 9 counties. And we asked a series of interview questions. The image here on the right-hand side of the slide shows you the survey that we used to conduct the study. 8 of the 10 homes, there were residents in them that said they experienced some type of chemical exposure symptom during the incident. As of February 18, when we completed the study, 4 of those homes had individuals that had sought medical attention for those events. We asked these individuals to rate on a scale of 1 to 5 their experience associated with these medical conditions, 5 being severe, 1 being no effect. And so there are a number of homes, almost about half of them, that rated something as a severe effect associated with exposure to this water. When we went to these homes again in mid-February, what we found was that many residents simply hadn't resumed water use activities. And through discussions and emails, I hear that many residents still today haven't resumed their full water use activities. What I want to bring your attention to is this graphic here. We have different water use activities on the x-axis, or the lower part of this figure here. And we have, on the y-axis, we have percent yes, which is before the incident, 100% of the people we talked to used water for laundry purposes. When I came in January, that number dropped drastically. So that number represents January 17th, and all of the homes that we had visited back in January with the university had been told that the water is safe to drink and you should resume your activities. So many people in January simply hadn't resumed their activities for laundry purposes. Well, in February, as part of the WVTAP project, what we found was that many people have now resumed laundry activities. But if you look down here, what you see is that there's still a sizable portion of individuals that over a month later still were not showering the water, about 40%. And then many people simply weren't brushing their teeth, cooking with the water, drinking the water, or giving it to animals. And we believe that's important. On the WVTAP database that we're posting online, it's a Microsoft Access database. You have access to all of these data. You have access to all of the comments that the consumers provided to us. And some of these comments are very telling. Certain consumers mentioned that they were not notified, and when they called the officials involved in the incident, the officials told them that their area was not affected despite having the licorice odor in the water. Some people's clothes smelled like licorice for weeks as they tried to get that smell out. And there was no information available for water safety for pets when individuals were told not to provide water to their children under 3. Many people said, well, what about my small chihuahua? What do I do with that animal? And there's still, to my knowledge, no information about that. Objective 2 was to examine the tap water quality in these homes. So after we conducted these resident interviews, we then went a step further and said, okay, let us characterize the water inside the house and also take additional water samples and send them to 2 different laboratories, one in California, one in Charleston, West Virginia, and actually the California laboratory had a companion laboratory in Pennsylvania. We also sent samples to them. We tested basic water quality parameters. We tested water pH like you would do with a pool. We tested free chlorine, disinfectant level, like you would do with a pool as well. We also tested turbidity, which is a measure of cloudiness of the water. We also tested the color of the water. Before we stopped that testing, we also did a quick sniff test. And so since I was here in January, I kind of knew what that licorice penetrating odor smelled like. And so what we wanted to do was compare that odor experience to what we were finding in homes. We also pulled water samples for what's called total organic carbon, TOC testing, PPH, which is one of the chemicals that has been talked about widely, as well as 4-methylcyclohexane methanol, or 4-MCHM. We sent our water samples to 2 different laboratories, and we did that because we weren't exactly certain what concentrations that we would find in these homes. Each laboratory, one was ALS Environmental Laboratories, one was Eurofins Laboratories. Each laboratory had different, what they call MDLs, or method detection limits, and method reporting limits, MRLs. And for additional clarification on that, I direct you to the WVTAP website. We have an excellent document that breaks it down into kind of very discrete and able to understand documents. TOC, we test for TOC, we test for PPH, and we tested for 4-MHCM. Water sampling was not trivial. For 2 weeks, Dr. Clancy and myself and Tim Clancy and another individual lived in the Sheraton. We lived in a hotel, but we didn't really spend any time there because we got up at about 5 in the morning and we didn't get back really until about 11:30 at night, and we just kept doing this over and over. And the reason why we did that is because we wanted to acquire all the data as fast as possible because this project is significant, and we wanted to make sure that we did it effective and appropriate. You can see here Dr. Clancy and Tim Clancy. Every night we were sending out water samples. The folks at the local packaging companies got us to know us on a first name. And over here, down in the corner, you see different types of equipment that we would set out on the countertop. Laboratory analysis, again, was conducted by ALS Environmental Laboratories as well as Eurofins Laboratories, and they will be talking to you a little bit about what they did as well. As expected, water quality differences were detected in these homes. We expected when we pulled some of them, we're not showering in the tap water. People were driving out of the area to take showers or finding other ways to bathe themselves. That was a continuing quality of life issue in mid-February after the spill happened. MDLs, or method detection limits for the chemicals that you're trying to find, are very important. And as we have seen, the MDLs in this incident go from 50 parts per billion to 10 parts per billion, now down past 2, and now we're at 0.5. So as these concentrations decrease in the system, it's almost that science is trying to catch up to find where they're going. And that's been a very big challenge. All home tap waters contain 4 MCHM, less than 10 part per billion. Maximum we found was 6.1, and about 90% of the values were less than 2.2. We did not find a relationship between the MCHM level in hot water and tap water and the MCHM level in the faucet inside the house. So there is no glaring relationship there. Odor types also were not attributed to certain MCHM levels. And I believe that's really important to understand because that licorice penetrating odor is not the odor of 4 MCHM. Our conclusions are, problem remains, more work is needed to truly understand what is going on in the system.
If I may, you're asking a very, very large question. You're asking a question that's not only about contamination, it's about political will and political process. And I think that that's beyond our scope. I'd be happy to talk to you offline about this. I clearly have opinions about this. Everyone involved, everyone on our team has been involved in the contaminant candidate list development. That is the process by which many of these things should be getting elevated to be looked at. It is a very complicated process to do regulations about individual or groups of chemicals. You need to know the occurrence of those. You need to know the health effects. And one of the things that we find is that when we sit down to do this with all good intentions, we seldom have a lot of data. We're in the situation that we're in with MCHM. There's not a lot of monitoring. You can't tell what the occurrence of something is if you're not monitoring for it, and very few people monitor for things unless they're required to do that. So what happens is when we do sit down to do these evaluations of chemicals that should be considered for regulation, we find that there is oftentimes very little data available. The data are very expensive to collect, especially the health effects data. There needs to be a political will, and the political will emerges from the people. And that means that people have to care about this, and certainly in West Virginia, you guys now care about this a great deal. Political will means that you've got to communicate with your legislators and people that you elect and tell them this is important. And we need more resources, we need more of a push to make this happen. I think this is beyond our scope to address here today. So I hope you'll forgive me, but I'm not going to pursue this further.